All right, guys. We're gonna finish up 4.1 in this video. We're gonna look at some other sampling techniques. So in the first part of 4.1, we looked at simple random sampling and then how to sample badly. So you have two different uh, poor sampling techniques. One of them being convenience, one of them being volunteer. Okay, so those are both poor. So again, with convenience sampling, you're just picking the people that are around you, something that's easy. And I said the example would be if I use the AP Stat students. Okay. For volunteer, right, that's where people have the option to respond. And again, I said that that's bad because only the people that care about what's happening are actually going to respond. And so the example I gave was the lunchroom. So if you don't buy food from the cafeteria, then you're not going to care about the quality of the food. So then you're not going to respond to that survey. So that's kind of the poor sampling techniques. And then we talked about simple random sampling, which is where you number everybody and everyone's got an equal chance of getting selected. So on this video here, we're going to talk about a couple of other techniques. Again, I got another activity to illustrate this. We'll go through this part in class. This is the difference between stratified cluster sampling and simple random. Okay, so we'll kind of talk about all those. But we'll kind of scroll down a little bit and we're going to talk about what is stratified sampling. So stratified sampling. So determine strata or classes, okay, or groups based on known facts about the population. And then from within this, so once you classify the population into groups, you then choose a separate SRS in each strata and combine to form a sample. Okay, so best example of this is going to be dividing the high school by class, right? So you have freshman, sophomore, junior, senior, right? And then you take an SRS, a simple random sample of 50 from each class, okay? And so now we have the additional control of age or class to help us guide our study, right? Because you guys know this as well, right? Seniors are going to be a lot more mature. They're also going to have a lot more knowledge than freshmen are. Okay, so you can divide by class, and then you can kind of see how the impact of something is, right? So you can look at SAT scores or something like that from freshmen to seniors. Okay, so this is saying. So if we want to think about this in like a short thing, is sum from all. Okay? We're taking some people from every single strata. So what's the benefit of doing this? Well, I kind of just talked about it. It adds additional control. So by dividing by strata. Okay, so age group is going to be one of the big ones. Location is another popular one. So think age/location. Like let's say we're studying the effects of social media, right? Obviously, younger people are going to be more impacted than that by older people, right? You can say the same thing about location, right? Places with higher income are probably going to have more social media, I'm guessing, than places that don't because they can afford those things. So yeah. This leads to less variability. And what you have is you have similarity within the groups or strata, but different between the groups. Right. So for example, if you're looking at freshmen, juniors, or freshman, sophomore, junior, senior, right? Seniors are going to be similar within themselves, right? But then compare that to freshmen, they're going to be different. Okay, so that's the idea behind stratified random sampling. Okay, so now what is cluster sampling? Again, this is just building off of everything else already. So cluster sampling is when you take, you divide into groups again, but you take every single person from a certain random sample from within the group. So write this out. So you start by classifying the population into groups of individuals that are similar to each other. So very similar to strata, which is why, again, this is going to be the vocabulary is going to be hard. But then the way you apply this is then you choose an SRS of the clusters. Okay, and then you have all individuals within the cluster are chosen to be included in the sample. Okay. So this is saying all from some groups. Okay, so saying some from all, you're doing all from some. And one of the benefits of this is that it saves time and money. Okay. So an example of this would be, we could divide the school. So write this down. So we could divide school by classrooms, right? And then take a SRS of all classrooms and use the individuals within, use all the individuals within the SRS. All right, so we've got a couple examples here. So the school librarian wants to know the average number of pages in all types of books in the library. The library has 20,000 books arranged by type, and shelves that hold about 50 books each. Okay, so explain how to select a simple random sample of 500 books. All right, so here you would just number each book from 00001 to 20,000. Okay, so you have some placeholders there, and then you can use table D or a random number generator to get 50 books. That's just using an SRS. But now the problem with this one, and you guys can kind of think about this a little bit too, is that it says here that we're divided by type, right? So the fact that we're divided by type gives you some indication of that we don't really just want a simple random sample, we want something a little more robust. So we could look at a stratified sampling, okay? And how could we do this with stratas? Well, we could divide the books by genre, because we know they're divided by genre. So by genre, okay. Number each book within each genre. Okay. Take a random sample within each genre. Okay. And there was how many genres? 4, I think. There is 1, 2, 3, 4. We don't know how many genres there are. Okay. So if I said there are 5 genres, then you could divide and then take 100 from each genre to get 500 total books or something like that. But we don't know that information. And then here, your genre is the strata, which represents the similar characteristics within the group. Right. So for example, all nonfiction books will be nonfiction, so on and so forth. Okay. How would you do it with cluster or with clusters? With clusters, you could divide by location. So you could divide by rows / columns. Number each row and column. Take a random sample of those. Use all the books in the randomly selected row or column. And here your cluster is divided by location. Okay. So what are the drawbacks of each of the methods? So cluster sampling is going to be cheaper. However, it's going to be less accurate. Has some more variability. Write this down. So cluster sampling is easier / cheaper. However, has more variability. Stratification then on the flip side has more variability, has less variability. So stratified has less variability, but more expensive, right? So there's a trade-off there. So it depends on what you're looking at, how you're studying it, what you're trying to do. You kind of have to make that decision. Okay, what is inference? So the whole second half of this course is going to be on inference. So it's going to be a pretty important topic. So inference is the process of drawing conclusions about a population on the basis of sample data. Okay, so this is kind of like the big idea of this whole entire course is that, okay, well, we hardly are ever going to have information on the population just because it's so difficult to obtain. So then, okay, we're going to take a sample, which is easier. What can we say from that sample about the population? Right. So that leads to a couple of things, right? We have sampling variability, which is the it shows how much an estimate varies between samples. So whenever you take a sample, you're obviously going to have some sort of, your sample is not going to be exactly the same every single time you take it, because you are using like a random number generator. And so you're going to have some variability. So is how much an estimate varies between samples, right? Each sample will be slightly different, right? So if I were to take, 10 students from our AP Stats class and average, and then got their average height, and then I did another 10, right? And I just used a random number generator to get those 10. Each time, while the averages may be close to each other, they're not going to be exact. They're hardly ever going to be exactly the same. And so that's what sampling variability is. And so then in order to compensate for this, what we do is we use margin of error. Compensates for the variability that results from taking a random sample. And so as we are going through an election year, right, you have all those polls, you have, 48 plus or minus 6% or whatever it is, right? That is your margin of error to compensate for the variability that comes from taking a random sample. So then that leads to the next thing. What's the benefit of having increased sample size? We have a couple of benefits here. Larger random samples give better / more accurate representations of information about the population. Okay, so when you have a larger sample, you're more likely to encompass everybody. Okay, and so as a result, you're going to have more representation of your population, and therefore you're going to have a little bit more accuracy. Last couple of things in this video. So what is sampling frame? A sampling frame is a list of all items in your population. The difference between a population and a sampling frame is that the population is general and frame is specific. So basically what you have to think about this way, your population, so let's say you're looking at like the people in Jacksonville, Florida. Okay, so then you have the population is all people in Jacksonville, Florida. Okay, versus your frame, your sampling frame is equal to the name of all those people from A to ZZ. Okay. What is undercoverage and what might this cause? So undercoverage occurs when some members of the population not be chosen in a sample. For example, a sample of households will miss all the homeless people, people in prison, students, right, and people in dorms, for example. The views of the people that were missed may be different than the views of the people surveyed. Okay. So think about if someone went around door to door during the day, right? You're only going to get people who are not working, right? And those people who are not working may have or may have night jobs, and those people may have significantly different opinions than those that are working during the day. So this can lead to bias. What is non-response? Non-response occurs when an individual chosen from the sample can't be contacted or refuses to participate. If the people who respond differ from those that do not, in a way that is related to the response, we can get biased results. So this one becomes really important when you think about voluntary non-response, because people choose to be a part of it. Okay, so that's where you're going to have a lot of these big issues. But even if you do a simple random sample, if someone chooses not to be a part of it, then they choose not to be a part of it. You can still have some non-response there. Now, what's the difference from voluntary response and non-response? Okay, so in non-response only occurs after a sample has been selected. Okay, so this is going back to the whole it's easy to get confused thing. So you can only have non-response once the sample has been selected. So let's say we're in class and I want to measure the height of 10 random students, right? But one of those 10 students doesn't want to be a part of it, right? But I've already selected those 10 students randomly, okay? Versus with a voluntary response, right? I could be like, oh, I want 10 volunteers to come and measure their heights, right? Well, I haven't chosen who those 10 are. They're going to pick it. They're going to pick and choose themselves. It's kind of the difference there. Last thing, what is response bias and what problems might it cause? Response bias is the tendency for a person to answer questions untruthfully or be misled to a answer. Okay, so for example, they may feel pressure to give an answer that is socially acceptable. Yes, that's what response bias is. So again, we went through a lot of vocab. Please ask questions as you need to, but that's the end of 4.1. Like I said, a lot of vocab. Definitely take some time to read through this, read the textbook, go through Quizlet. If you have any questions, guys, please let me know.